so far, for getting all the way up here in the mountains to be with us tonight. I'd also like to say hello to the people watching on the live stream. I know it's very late for some of you. I'm really grateful to be here tonight in this beautiful venue, in this beautiful city, with these wonderful people. My name is Sebastien Couture. I'm the founder of Interop Ventures. I'm also the host of a few podcasts, Epicenter and The Interop. And we're here tonight not because of the great venue, not because of the great food, because of the great view, but we're here because we share values. We share the values and we believe in the power of open, permissionless technologies. We also believe that privacy is a fundamental right. As you know, there are people right now who are paying a high price for believing in these values. And this is why it's so important that we keep talking about them, that we continue to affirm their importance, and more importantly, that we never stop building. So last summer we organized Nebula Summit in Paris, and we brought together a community of people building cutting-edge interchain technologies and who believe and share in these values. And we're so pleased to be partnering with Enoma tonight, and I feel incredibly grateful for the opportunity to do our second Nebula event here in Medellin. So please give the Enoma team a great round of applause. Urbano, Chris, Philip, Ava, Adrian, thanks for making this happen. We have a great evening planned for you tonight with folks who also share these values and who will tell you on how they're contributing to help keeping them alive. A little bit of housekeeping. There'll be a break at 7. So we have 2 talks and a panel, and then a break, and then 2 talks and another panel. We'll be serving drinks and food throughout the night. Washrooms are here in the back. And there will also be buses shuttling people back to the center later in the evening. Feel free to explore the grounds as well. The garden in the back is very, very interesting. And yeah, without further delay, I'd like to open the stage to our first speaker, Zaki Manyan.
How's it going? All right, cool. All right, so this is mostly my talk from yesterday, but we're gonna go deeper into Atom 2.0. This will be like one of a number of going deeper. Also, how do I figure out what time I'm done? Who's watching the time? Okay, cool. Someone throw something when I'm supposed to get off the stage, okay? So we'll use that system. Okay, so we're gonna go deeper into Atom 2.0. That's basically this talk. So like stripped out a bunch of stuff and wanted to go, okay. All right, so yes, 2016, we sort of conceived Atom 1.0. To people who did not hear my talk, so why did just like, who didn't hear my talk and have somehow been sleeping under a rock, the people who, like the reason the sort of motivation of Atom 2.0 is that we seem to have created, or we have created this amazing interchain ecosystem that is on display at this conference and on display at this event. But we've also sort of created a bit of a, like, this is us. The lowest fee value accruing asset, like in the top N assets. We've created this like essentially meme coin for the interchain. And what we wanted to do in conceiving of Atom, so like part of the challenge has always been like, the way I describe it is, our thesis is application specific blockchains. What is the application of the Gaia chain, the Cosmos Hub chain? Like it doesn't have an apparent application. It just sort of exists. It does proof of stake. It demos, hold on. Like this system that we like posited in the Cosmos white paper as like a coherent proof of stake economy like actually functions. which is like not a trivial accomplishment at all. When we launched the Cosmos Hub in 2019, proof of stake was still something that was viewed as experimental. It wasn't really clear whether or not it could produce like a secure, decentralized ecosystem. So it was a huge accomplishment to like prove that proof of stake works. But it's kind of incredibly boring to have our sort of foundational blockchain only represent like basically, look, proof of stake works, IBC works, and do nothing else. So this led a group of people who are the authors of the new white paper, who've been working on this since early January, late December, to sort of start conceiving of, hey, like what if Atom had a purpose? And so a lot of people contributed to this. Sam Hart did the hard work of turning like this giant hodgepodge of ideas into a coherent white paper that you can all read. And so we're going to dig a little bit more into like the constituent elements of the white paper. Okay, so 3 legs of the stool. So the first leg of the stool is, again, we like demonstrated that you could like run this proof of stake economy, that it would work, that like people would actually stake, that there would be viable economic incentives, that the thing would be secure, that the validator set would dynamically evolve over time, that it wouldn't collapse into a system that was like only run by like a couple of companies or foundations. So huge accomplishments, but like also staking in Cosmos has lots of obvious problems. One is the enormous dominance of centralized exchanges in the validator set of the Cosmos Hub, and any chain that like matures enough to be listed, you quickly find yourself in this situation where you have like hyper dominance of the validator set. So what we are talking about is really embracing the world of liquid staking providers and making Atom into a better asset for using in DeFi. Like one of the other observable problems with Atom right now is that it is like strangling the DeFi economy in many ways, because the sort of risk-free rate is 19%, and it becomes really hard for anything other than DEXs, which have a large amount of inflation, to compete with that through their liquidity incentives. So like, we need to stop strangling our DeFi ecosystem. We also, so like in a world where all of this is true, it seems clear that we have a reduction in the need to issue more atoms to pay for a security budget. So issuance can go down, issuance can be repurposed for other things. There's an enormous sort of write-up of like this proposed new issuance schedule in the white paper that I am not going to really focus on in this talk. It's best focused on in the white paper because it has like lots of graphs and moving pieces and stuff like that. But a big part of this idea is a mental shift now away from Atom is this like infinitely and like the paper proposes like moving to a 300,000 Atom a month linear issuance schedule after 5 years. Okay, so another problem in our ecosystem is that like we don't believe in the flat protocol thesis. The meme about Cosmos is the Cosmos is coming to kill the flat protocol thesis. So how does Atom align? Like, it's clearly not a fat protocol. All these things are not built on top of Atom. They don't have to use atoms for fees. So how do you actually align Atom with this ecosystem that's built using the technologies that were born out of the development of the Cosmos Hub? Another problem that that like sort of motivates the idea of the allocation module is this idea of we don't want, like what we've seen is sort of a variety of exclusionary, rivalrous, adverse selecting mechanisms for trying to capture value. Where like you push the best, like one of the greatest things about Cosmos is like how many of the biggest brands, the best projects have come to an ecosystem that literally did not have a business development team really at all until like a few months ago, and like has one of the smallest business development teams. Yet we have like most of the centralized exchanges that have their own chain build a Cosmos chain. most of the centralized and like use our tech, you know, and like we are seeing an increasing amount of migration of like the biggest brands in DeFi also to the Cosmos, and all of that is like without BDs. So you don't want to like kill that process by like saying, hey, if you want to connect to the Cosmos Hub, if you want to get some other benefits from the system, you have to like, you know, do like a crowd loan or any of this other stuff. So what we really want for Atom is a way for Atom to instead align itself with all of these new things that are coming to the ecosystem. And then the last piece is this, what we call the scheduler, which is basically a block space futures market, where we think that another aligned way for Atom to benefit its ecosystem and sort of align itself with its ecosystem is by offering a place in which you can buy future block space. I've heard like the MEV panel today was, I think, like one of the best panels of the whole conference. We're going to see a lot more. There's also a MEV roundtable later tonight back down in the city. I think MEV is going to be, you know, is like one of the most esoteric topics. It's also one of the most important topics for value accrual in the system. Skip also made like this really exciting proposal to capture MEV and internalize it on osmosis. So again, I think you're going to see MEV is going to be a big part of it, but like this is a sort of cross-chain MEV architecture. Okay, so this is what I just said: adoption of liquid issuance, fixed or negative issuance. So the white paper proposes fixed issuance. I don't like the white paper is not. I don't think of the white paper as like, oh, these are like finalized parameters or these are like the way things have to be. It is largely a starting point of a discussion because like the people who have been involved in the sort of construction of these parameters are like a limited subset of all of the stakeholders who would care about Atom, right? And so it's like a starting point and it's an anchor point for the discussion, but anchor issuance is going to continue to change and evolve also over time, regardless of like what we write into software in like the process of executing on this Atom 2.0 vision. So formal cap is possible, and then we have this new issuance schedule that's in the paper. And I guess the biggest thing that should make people highly confident that like Atom can actually transition to this new issuance schedule is the sheer number of liquid staking providers. Okay, so I think one of the like least understood things, I'm just going to get at like one point because I don't have that much time left. One of the least understood things about the MEV scheduler is mostly the discussion about MEV tends to involve like sandwich attacks on DEXs and you know, liquidations and the MEV opportunities that come from that. But the real key piece, the real thing that actually matters, the largest source of MEV in the blockchain ecosystem is literally exchanges being able to see when you clicked withdraw funds from the exchange. And basically what we're trying to do, more than anything else, in this proposed MEV scheduler is, yes, we are trying to create like a new way of creating like amazing multi-chain DeFi user experiences. We like are trying to create a world in which like a block builder can like buy the ability to like move Atom over IBC to Agoric, mint IST, and go buy something on osmosis in one like continuous, highly reliable way, far more reliable than like the sort of ad hoc block building that we do right now and ad hoc relaying. But we're also trying to create a world where we actually start to internalize back to the community a lot of the value that these centralized exchanges are going to be able to extract just because they have insight into when people enter and leave their own systems. So yeah, this is sort of this mental model of like what we want people to be able to do, which is buy like contiguous elements of block space. One of the reasons why we think the interchain scheduler is going to be compelling rather than every chain running their own scheduler and may extend beyond the interchain secured zones, the interchain secured consumer zones, is we think that it is a far better product for the builders to be able to like buy contiguous space over as many chains as possible so that like these kinds of like contiguous executions across multiple chains of actions can actually be executed with a high degree of confidence. All right. Last piece of the whole thing is this allocator module. And without a doubt, I think the allocator module is the most ambitious, high-risk thing. I think it's also worth remembering that like the amount of atom emissions, the amount of atoms that are ever going to be allocated to this thing is going to be relatively small. It's not, again, like we're trying to like, you know, double or triple or quadruple the supply and allocate it all to the allocator module. It is a mechanism that may be very productive, but like what I really think it does is it like answers this question of how do you partner with the hub? Right now, and how do you partner with the Atom community, which has been a big unknown for new chains that are launching in the ecosystem. You know, the Atom community has liquidity, it has exchange integrations, it has all of these things that are valuable to everything in the ecosystem, but there's no actual mechanism of like structuring a partnership. And so, what we're trying to do is really make, more than anything, the idea of partnering with the hub a viable idea through having these mechanisms where, you know, inflation can be streamed out to economic use cases. Like one thing that, you know, immediately comes to mind, for instance, is like, oh, like you've launched a stable coin, that stable coin is backed by Atom. Well, why don't we buy like Atom, that stable coin pairs, and have them sit in the treasury? I also think of this as like largely a very long-term mechanism as a way of like integrating with the this isn't about like quick rewards. This isn't about like flipping coins that go up, you know, 5,000x into the ecosystem. This is mostly about building long-term economic partnerships between the sort of Atom DAO and other DAOs that exist within the Cosmos ecosystem. And so, you know, to close, like, what did I mean by this? What I meant by this is, you know, both the allocation module and the scheduler do provide an opportunity to introduce fee burning mechanisms. We didn't put that into the white paper, but like this is a thing that the community will get a handle on over time. So thank you very much.
Thank you, Zeki. Thanks. So our next talk is by the Anoma team. Yep, Adrian.
I'll be very brief. We have a timer, amazing. That timer is wrong. There's like 15 minutes, but anyway, very quickly. So, if you've seen my talk today at Cosmosverse, this will go over the same things in 3 minutes as a speed run. So, Anoma, one architecture for full stack decentralization, quick historic. Whoop. There we go. Started with scriptable settlement, Bitcoin, had a long tail of Bitcoin forks. Pretty much it worked, but it was clunky for most major applications, and as a result, we ended up getting programmable settlement, where all of a sudden colored coins became ERC20s, named coin became ENS. Yep. Then we went into programmable settlement plus, which is really the idea that we can move away from proof of stake, proof of work to proof of stake. We can get rollups, we can get things like sharding, we can get things like Tendermint, and advances in privacy and advances in languages. But in the end, it's still exactly the same model as programmable settlement, just in a slightly different color. Like to me, the distinction between something like Near, Solana, and Ethereum is very marginal because to an actual developer, what is exposed to them is an imperatively executed VM that runs at a slightly different speed with a slightly different language with slightly different opcodes. But it's like it's an imperatively executed VM, and that's all it does. And the big insight is settlement is not sufficient. Most actual interesting applications need something else rather than settlement. Settlement is sufficient if I want to pay my friend, because then I already know the counterparty that needs the money. If I want to do anything more complex, like I want to trade some ETH against a CryptoKitty, I need counterparty discovery. If I want to do any sort of trading, if I want to do right, what are the 3 current approaches to do it? You dump it all on a blockchain. this is incredibly silly because now we're establishing global total order on a thing that doesn't need global total order. You dump it all into a single operator database. This is what everyone else does because that's like the cheap answer to this. But now you're a centralized thing that in the best case can't steal money, but in most cases can definitely censor and prevent people from using these systems. Or you dump it all on this app-specific sovereign chain, but now you lose all composability between these different kind of intents that people have. And this is really the big thing. Programmable settlement gave us composability at the settlement layer, and we now need composability at the intent level, where I can build a new application on the intents that get sent to the Optimism solver as well as the OpenSea solver, and I can build a new application that takes advantage of those two things. Right, this leads to ANOMA, one unified architecture for full stack decentralization. And really here the tagline is, ANOMA is an intent-centric, privacy-preserving protocol for decentralized counterparty discovery, distributed solving, and atomic multi-chain settlement. There's a lot to unpack here, and Nakeeb is going to talk about Typhon in a second. But the key takeaway is intent centricity is what matters. People have intents, they don't have transactions, and generally everything that's interesting needs counterparty discovery. And so there is sort of, this is the third generation of architectures. We went from scriptable settlement on Bitcoin to programmable settlement with Ethereum to intent-centric, privacy-preserving, like decentralized counterparty discovery with ANOMA, and I expect there will be many ANOMA-like architectures being deployed over the coming years because this is sort of the obvious way, next step to decentralize a bunch of things. Yeah, that's it. Nakeeb, go ahead.
Can we get the updated slide deck? Hi, my name is Nakeeb. I'll be talking about Typhon. So I have a lot of ground to cover, but I don't have much time. So I'll be rushing through the slides, and if you have any questions, please find me, and I'll be happy to explain more. Okay, so Typhon. Typhon is an open source specification and library, which, if desired, can be adopted independently of other parts of the ANOMA protocol stack. And we basically hope to extend the Cosmos ecosystem by providing an alternative to Tendermint. Okay, so a quick shout out to the rest of my team. So we have Tobias, we have Isaac, and we have Alexander and myself. So in this talk, I have like two parts. In order to truly understand what value Typhon brings to the table, you have to understand what limitation Tendermint has. So I hope that at the end of part one, you will understand what those limitations are, where they lie, and why they exist. And at the end of part two, hopefully, I will convince you that Typhon truly solves those limitations. So let's look at part one first. Yeah, part one, part two. Part one. Okay, so currently ANOMA-based blockchains use Tendermint as their main protocol to order, execute, and store transactions. I personally very much like Tendermint. I think it's simple, it's elegant, it has proven to be resilient in different scenarios. And also Tendermint is becoming the de facto standard for Cosmos-based blockchains, which I think it makes sense because it decreases ambiguity and it's also decreases the cost of integrating several components into the ecosystem. But Tendermint is not perfect, and the three main limitations I wanted to talk about today is performance, censorship resistance, and its fit in a multi-chain world. Okay, I have to back up my claims, of course. So there are multiple studies that show that Tendermint has performance issues. In this figure on the left, we see that it does not scale well with the number of validators. And on the right, we see that Tendermint's throughput and latency is significantly worse than its alternatives. And this is a problem because performance is currently one of the major factors that is holding back mass adoption in blockchain systems in general. So we need to address this issue. Okay, so there are a few reasons why performance is bad in Tendermint. And essentially, they all come down to the fact that Tendermint has an inefficient block proposal mechanism. So unsurprisingly, the speed at which validators on blockchain converge severely is affected by the latency of communication in the underlying peer-to-peer network. And two things that contribute to this latency are the size of messages and the frequency of messaging. So regarding the size of messages, Tendermint requires that each proposal message includes the full text of transaction in the proposed blocked, and simply marshalling and unmarshalling those large messages has proven to be a significant bottleneck in Tendermint. And regarding the frequency, Tendermint requires all-to-all communication. So validators might redistribute transactions that already have been distributed before, which is inefficient. But even if we achieve a small overall message complexity, Tendermint still relies on a single leader to disseminate proposals and to coordinate consensus. And this imposes high load on a leader, who then naturally also becomes a bottleneck. And as a consequence of this centralization, validators need to have sufficient resources available to act as leaders, but most of the time they are not leaders, so most of the times they do not utilize their resources to their maximum capacity. Okay, so the second limitation of Tendermint is that it has a poor censorship resistance. And by censorship resistance, in this context, I mean that the suppression of user activity nor information should be suppressed. So in blockchains, if users intend to make valid state changes, they should be able to do that. And so the question is basically, how long can the adversary keep transactions which are submitted by honest users from being committed to the blockchain? And Tendermint's architecture gives round leaders basically all the authority to decide which transactions to include and which transactions not to include in the next proposal. So we can compare this level of authority to kings in Westeros, right, in Game of Thrones. So suppose our protocol states that leaders should propose transactions in the order they have received them, for fairness, and assume that they can only include 2 transactions in the next block. Then the Mad King, which we see here, has 4 candidates, and according to the protocol, he should marry Cersei Lannister and also feed the people of Westeros. But he censors those transactions, and instead he proposes the last 2 transactions with big consequences because his proposal gets accepted, he ends up marrying his sister and keeps the bloodline pure, and he also, and he also burns all the people of Westeros with Dragonfire. Now, the way Tendermint adds resistance is by changing the round leader every X rounds. And so in good scenarios, the Mad King will be replaced by a king that is like less mad, for example, Robert Baratheon. But there's also a bad scenario because the Mad King might be replaced by, for example, King Joffrey. And what I'm trying to say here is that honest transactions have to wait for honest proposers. And this can take a long time. And Byzantine leaders, just like bad kings, will always come back in some future rounds because Tendermint has currently no mechanism to detect this type of behavior. So the third problem of Tendermint is that it is not optimized for a multi-chain world. So IBC is amazing. It enables cross-chain access to information, but we want to give access to cross-chain functionality. And while doing so, we need to keep one thing all the time in the back of our minds, which is that chains must remain sovereign all the time. So they must have full autonomy and control over their own information and functionality. And each chain can have its own security model based on its own set of validators. So the reason why I'm saying Tendermint is not optimized is because we see that cross-chain functionality implemented on top of Tendermint is using multi-phase commit for these things. Those are complex and not safe in certain situations. So I will skip over this example, but like a three-phase commit have multi-phase commit have 3 problems, which is liveness, speed, and game theoretic advantage. Yeah, I'm not sure if I have time enough for this, but yeah, I'll just come and find me. So Typhon solutions. In order to understand how Typhon does this, so in order to understand how Typhon solves Tendermint's limitations, it's helpful to understand its high-level architecture. Typhon is composed of 3 separate layers, where each layer passes information onto the next layer. And so the mempool is constructed in such a way that it improves Tendermint's block proposal mechanism. It's based on Narwhal, but we tweaked it a little bit to allow for heterogeneous settings, which I'll get into later. The consensus layer improves performance, censorship resistance, and is more optimized for a multi-chain world. It's based on heterogeneous Paxos. In addition, we'll also enable a new technique, which we call Chimera chains, which help us update state on multiple chains in multiple in an elegant way. So finally, okay, some skip. I'll skip this as well. Sorry about this. So Typhon's mempool solution is that we can have a more decentralized way of sending information around by logically separating the responsibility to disseminate information and to coordinate consensus. So this will hopefully remove the bottleneck I was talking about before. I really want to talk about Chimera chains. So we propose that instead of doing like complex multi-phase interactions, what red and blue chain need is a third chain. And on this third chain, which we call Chimera chains, cross-chain transactions can take place atomically. So in our previous example, so we had like a badge that contains transactions where you booked a hotel room, and you had a chain that keeps track of transactions of plane tickets, and ideally we want to have them committed at the same time. So they should be either committed both or none of them. And the way we do this is using Chimera chains, and the reason why we do this is because this allows us to not lose safety or liveness because of something that happens outside of, for example, the red chain. And this holds also, of course, for the blue chain. And we will achieve this by using heterogeneous Paxos, which is our own consensus mechanism. And this gives like specific failure tolerance on which we can commit these atomicity guarantees. So for your intuition, the Chimera chain is like a trusted bridge, and you can run transactions on them, and you can get this atomicity under certain trust assumptions. And these assumptions grow naturally from quorums of validators on each chain. And the more validators 2 chains have in common, the stronger the atomicity guarantees. That's like the main thing about it. And let me go, continue. Okay, I'll skip this. So Typhon's the consensus layer on Typhon solves basically Tendermint's performance, censorship resistance, and is more optimized for a multi-chain world. So we improve the performance because we need to reach consensus on less bits, because we work with references, and because heavy dissemination and chatty consensus protocols are like decoupled from each other. And the third reason why we improve performance is because we don't lock states in multiple rounds in our consensus protocol. And we improve censorship resistance because every proposal is guaranteed to have at least some honest transactions. And Typhon is also more optimized for a multi-chain world, as chains remain sovereign all the time and delaying is not incentivized. So yeah, that's Typhon. It's Tendermint's spiritual successor, as Chris would put it. The ANOMA framework will hopefully help people build Cosmos blockchains and using Typhon, and hopefully also enable Chimera chains. Thanks for your time.
Thank you so much. So now we have a panel. As we're getting set up, I'd like to introduce our moderator, Ava from the ANOMA team.
Test, test. Yes, this works. Okay, roll call. We got Adrian,
Yep.
Susanna.
Hello. Did my mic work?
Yeah, that works.
Hi.
We got Nick. Yes. Sunny.
Hello.
And Ethan.
Hi.
Awesome. Okay, so here we have a panel. Oh, I'm Awa. I'm one of the co-founders of Anoma, and I have the pleasure to moderate this kick-ass panel. I hope it's going to be spicy. I don't like panels when they are not contentious at all, so let's see how it goes. Cool. Why don't we start with a very quick intro about yourselves, and so explain who you are, what's your background quickly, but then also explain when was the last time you used a blockchain and what it was for. Wow.
Okay.
This is really hot panel.
Quiet. You? That's supposed to happen? I don't know. Okay.
It's totally planned. Who wants to start? Quick intro to yourself and explain when was the last time you used a blockchain and what for.
I'm Nick. I'm building Celestia, which is the first modular blockchain network. And I'll be speaking tomorrow, so stop by my talk at noon. Last time I used a blockchain was actually, I used Osmosis, and I was compounding my staking rewards.
Hello, my name is Sunny. I work on Osmosis. It's a DEX built on Cosmos. Last time I used a blockchain was today. I bought some Axelar tokens on Osmosis.
I'm Ethan. I'm a Tendermint engineer. I'm still reeling from that full frontal assault on my my life's work, the last talk. So, you know, really appreciate that. Last time to use a blockchain was a couple weeks ago. I think I signed an Auth-Z transaction to enable Cephalopod to. Oh, hello. I got censored. Blockchain was right now to overcome this censorship of my microphone.
I missed that. Cephalopods what?
To grant Auth-Z so that Cephalopod could vote more easily.
Ooh, okay, cool.
Hi, I'm Susanna. I work in the IBC team as the product lead. I'm relatively new in Cosmos compared to pretty much everyone else here, but I'm very happy to be here. And the last time I used the blockchain was actually my friend staked all of their Osmo and couldn't unstake it, so I sent them some Osmo so that they could actually unstake.
I'm Adrian. I've been working on blockchains for a while at this point. Last time I used the blockchain was actually like 2 days ago to act as a relay into the Swiss banking system. I receive USD and I send Swiss francs.
Money transmitter.
In a very small capacity, not a money transmitter.
Okay, awesome. Cool. Just a quick rule. When I ask questions, I think not more than 2/3 can agree at all times. So, like, make sure that somebody listens.
Anti-consensus.
Yes,
It's
exactly.
the typhoon consensus.
All right, cool. So it looks like recently we have very quickly moved away from the idea of there's going to be a world computer, one blockchain that dominates everything. Bitcoin's going to rule over everything. We're going to price milk in Bitcoin or in ZEC or whatever. And so what are you guys' thoughts on, like, are we in the multi-chain world or the interchain world? What is the difference there?
I mean, I'll take the opposing view. If you look at actual value, still a lot of stuff is just happening on the world computer, as in Ethereum. I have to say, though, that personally I think this is going to change pretty rapidly in the coming month. But currently, we still very much live in a single blockchain to rule them all world.
I think, I feel like, we've moved away largely from this world computer view. I think the question that is still open, I think the new interesting question is there a single settlement layer or many settlement layers? So, Ethereum has basically switched into this multi-chain view with their whole roll-up system, but their whole philosophy is, we're still going to have a single final settlement layer, which is the Ethereum base chain, while I think Cosmos takes the approach that, no, every chain is its own settlement layer for its own native assets and its own state.
So I think the world computer is a dumb metaphor, and I'm personally an advocate of the community computer, and I think we're undergoing a community computing revolution. And Celestia is the kind of end state of that revolution potentially. And I compare this very much to personal computers and mainframes. Mainframes, the personal computing revolution was well underway, but mainframes were still quite dominant. And in a similar way, the community computing revolution is well underway, but the mainframe community computers, we could say, are still somewhat dominant in the form of Bitcoin and Ether or Ethereum, and that will start to change.
I mean, I think sort of the best analogy why I think we're going to leave this mainframe world and going to move to local blockchains is simply because, like, no one in Europe currently likes the idea that all their social networks are controlled by like 3 US tech companies. Like, my parents don't trust the US financial system, but for some reason, like, their security is checkpointed into that financial system. It seems very unlikely that once we've rebuilt this entire stack, that we're going to end up in a world where we all checkpoint into global ETH. People want to control their own security domains, and people want to control their own financial systems.
To extend Ethan's metaphor about the community computers and like mainframes being sort of like the dominant form of community computing right now, Celestia's vision is that rather than every community computer kind of operating at its own server, its own like hardware, its own network, that we can build things that are sort of analogous to cloud computing for Web 2, where there's shared infrastructure, very scalable, affordable, on-demand infrastructure for people to deploy their Web 2 apps. We can build a similar system for Web 3, where there's a shared sort of data and consensus network on which any community can quickly deploy their own community computer. That's our vision.
Before we dive too deep into modularity, I kind of want to explore a little bit more of the idea of just interoperability, right? Bridges and IBC. I think over the last year, we finally see that technology being more adopted. I kind of feel like 2 years ago, we were still more in theory, still being shipped. So how do you guys feel about interoperability, cross-chain? What about the maturity of that ecosystem? What are the challenges that you see at the moment?
Well, I mean, from my perspective, I think the main challenge is if we assume, like, kind of what we were just discussing before, there's not just going to be one blockchain. Hopefully that's going to be many, but like the way to really harness the power of that is to have this communication between them. And I think like achieving some kind of standardized way for blockchains to have like their own choice in settlement layer or their own choice in like a data availability layer, but then to actually have something which is going to unify everyone. So having a standard which is like widely adopted, I think is maybe like a challenge in the blockchain space generally, but hopefully IBC can solve that challenge, at least to some extent, and not just within the Cosmos ecosystem, but more broadly for all of these other blockchains as well.
Yeah, people don't know this yet, but everything will speak IBC. As in, like, Ethereum will speak IBC, and all of a sudden the definition, like all of a sudden the question becomes, is Ethereum part of the Cosmos ecosystem? And depending on how you define this, the answer is clearly yes at that point. So will Bitcoin, by the way.
I think with the get out. I think right now, like IBC is like still really focused around like token transfers, which is like, the very simple, easy thing. But the whole point of IBC was like, have a lot of, and we're seeing a lot of these new functionalities actually starting to finally roll out now. So, how it took like 3 or 4 months between like IBC token transfers launching and then like Osmosis launching to actually like kick off real usage of it. I think we're in that phase right now with a lot of these new things like interchain accounts, interchain queries, like the stuff that's going to be actually make IBC really cool is like, and we're seeing like Stride is like probably the first thing that actually makes use of interchain accounts, but I'm sure we're going to see like a lot more starting to be deployed in the coming months, and so that's when I think the IBC ecosystem gets like, it actually has cross-chain composability.
Okay, so far very amicable. I see some potential for collusion here.
okay, I mean, here's like one thing, you know, I don't know if it's a hot take, but I feel like somehow in Cosmos we've memed the idea that IBC is not a bridge, when it's like, everyone's like, oh, don't use bridges, use IBC. It's like, guys, it's just a type of bridge. It's a, you know, it has better security properties, but the same kinds of things we should be thinking about for like bridge risk, we also should be thinking about for IBC, you know? I mean, IBC is well audited, thanks to the Informal team, but like, there's always, you know, we have to be careful. You know, so one thing is like, I think one of the solutions for all security things in general in all of crypto is just more rate limiting based systems. We need circuit breakers. Yeah. So the Axelar team actually just added like 2 or 3 weeks ago, where there's only, on the Axelar bridge, you can only move a maximum of $5 million every 6 hours. So that way, if there's ever a major hack or something, you know, we can cap the amount of losses that are in the system, and it gives time to pause it. So, you know, we really like that idea, and we actually started implementing it at the IBC layer as well. So, you know, not the upgrade that's happening this week, but you know, the next upgrade will have IBC rate limiting, where you can like say, hey, only this percentage of a channel's TVL can be like moved every X number of hours or something. So, you know, IBC is great, but we still have to really be thinking about the safety features that go into it.
I would say the distinction between a bridge and IBC makes a lot of sense. A bridge is like, there's a third party involved that does some routing that you now have added into your security model. Whereas IBC is like a point-to-point routing system where like you care about the security of this thing you came from, and you care about, or that issued the asset, and you care about the security of the system you're currently on. But you don't have to worry about like the bridge in the middle, which is like another, sometimes it's a glorified multi-sig in the case of Polygon or Wormhole, and in other times it's sort of a decentralized multi-sig in the form of a blockchain that does routing for you. But I think that's really the distinction between like, this is IBC and the rest is like bridges.
Well, I actually think like bridging is just like one specific use case of IBC, and I think like everyone associates just generally moving tokens between blockchains as bridging. So like, yeah, for sure the biggest like product market fit of like IBC so far was the token transfer. It was designed to be like generalized message passing. But for instance, like I think the only real use case of generalized message passing is from Injective, who are like streaming an Oracle data feed from BAN protocol. So like in that sense, yeah, you could say IBC is predominantly a bridge so far, but that's like just the initial functionality that people have really like wanted to use. But yeah, I think there's really like a lot further to go, and interchain accounts, interchain queries, more sophisticated workflows with token transfers, like sending your token and then immediately executing an action. There's like lots of stuff coming up, and it's still early days, right? It's only like 18 months since it was launched, and yeah, I think.
Interchain security.
Okay.
Mesh security.
Shared
Bring it
security is a
on.
meme.
Shared data layers
Oh god.
Doesn't make sense in Polkadot either.
and rollups.
Okay,
No,
so
but
we
one of-
got. Go ahead. Go
Just
ahead.
one of the powers of IBC was that, you know, it was designed as a general purpose communication protocol above which we can build arbitrary, you know, coordination mechanisms. And so while many other projects, you know, they focused on bridges or they focused on, you know, a sharding layer or something like that, we build IBC, and then we can go sort of bottom up and build sharding or other kinds of, you know, cross-chain coordination using IBC. And so now that we have IBC, it opens up all these possibilities to do interesting things like interchain security or mesh security, or, you know, the holy grail of running Tendermint itself, or whatever the new thing, what's it called, Typhon? To running Typhon over IBC. Well, obviously we won't implement Tendermint, that would be dumb, right? But to, you know, to actually start implementing like distributed systems protocols on top of IBC, using IBC as, you know, a generic transport layer like TCP, I mean, this opens up all kinds of new interesting possibilities, so.
All right, so we got sovereign chains, we've got bridges, we've got IBC, we've also got modular blockchains. I guess this new idea that sovereign chains can focus on providing a specific feature to other sovereign chains, like for example, data availability. How do applications look like in this kind of ecosystem? Are there any kind of trade-offs in security models, for example, UX perhaps?
There are definitely trade-offs. There's a lot of benefits. So one of them, since we were just talking about IBC, is that if you build roll-ups on a shared data availability layer, you get trust minimized bridging in a true sense. So even with IBC, I mean, obviously, there's a lot of nuance because there's interchain security, but the bridge fundamentally makes an assumption that the counterparty validator set is honest and secure. And so if that assumption fails, then funds can be stolen, things can go wrong. And so in a modular sort of roll-up with a shared data availability threat model, you don't have that risk. Of course, there are other risks and other challenges, like you have to build the execution. First of all, data availability layers don't exist yet. We're building, hopefully, the first one. And then roll-ups are also challenging because you have to make the execution of that roll-up fraud provable or validity provable. And that is like no small feat, but I do think it's achievable, and lots of teams are working on it, soon TM. So that's one of the big advantages, I would say. And the other advantage of a modular setup is that you can reduce the bootstrapping cost for launching a new chain. Again, interchain security does the same thing, but in a different way. But essentially, with a roll-up, you don't have to create a new consensus network from scratch. You just have to deploy, like you have to have a sequencer. That it basically acts as like the block builder and proposer. So it can really reduce the overhead to launch a new blockchain.
To your original question, though, about like service provider blockchains, right? I mean, I think that makes a lot of sense. There's, Osmosis, we've always been like really big believers in like vertical integration and like, owning like the entire stack from top to bottom. But then there are things that we realize that like, hey, this is just not worth our time to do. And like, how we use Axelar, for example, right? We were like, okay, bridges, hard. We don't want to be the ones to build it. There are a lot of projects that maintain their own bridges, and we're like, you know what, that's a lot of work. We're gonna like outsource that, but like build really close partnerships with like with these service providers. So we ended up doing something similar with lending as well, right? We were building our own lending protocol called Isotonic, but then the opportunity to just like work very closely with the Mars team, and it was just like such a good fit that we abandoned ours and like, build just closer relationships. So I think, yeah, having these like, pieces of the stack come from other chains makes a lot of sense to me.
I think sort of the counterpoint to this is that as a user, if blockchains service other blockchains, your security model from a user perspective becomes incredibly complicated, because now you not only need to think about what the security model of Osmosis is, but also you sort of have this joint security model of Osmosis plus Axelar if you touch specific assets on Osmosis. So actually, I can see why individual blockchains may not want to be service providers to other blockchains, but rather individual blockchains run the entire stack in their own security model, so that as a user, you very much know which security model you're interacting with. And what ends up roaming is like users roam between different different security models. So like there could be Osmosis in
Mesh security fixes this though, right? Because then Osmosis and Axelar both have the security of both of their tokens combined.
To some extent, yes, this fixes it. But then the thing is, now you just created a new blockchain, which is this joint security model. I would say that from a sort of a more practical perspective, like what's easier to understand from a user perspective is like, I care about this specific architecture, but I want this in a different security setting. Like I may want like an Osmosis-like feature set controlled by my local government because I trust my local government, right? Or the corollary to this is like, I may live in Argentina and I don't trust my local government, so I want global Osmosis security, or whether it's Osmosis plus Axelar security. But I think we should like be able to very differentiate the idea of architectures from security models, because it makes it easier for end users to think what they're actually getting into. This is why, like, if there's only one global security model, everyone is now forced into this global security model. So I think a better UX perspective is that like users roam between security models, and we don't just have one global messy security model.
Who are these mystical users that are capable of reasoning about security models in this way?
Wallets do it on...
Are they in this room?
I think that the wallets do it for the users, right? Like, I think the onus is on wallets to like provide like proper security recommendations to their users. It's like, you don't, when you use a wallet, you don't think about like exactly how much gas to put in or something, right? It's like the wallet just tells you how to do it.
I do think about
To be
that.
fair, I would say that everyone in this room has a very clear notion of local security models, because as soon as you step foot onto a plane, you like change your local security model, and everyone is very well aware of this. So actually, I think this comes much more natural to people than we think if we sort of bring the right analogies also into the blockchain space, where people can understand that this is like very much like, oh, you're picking up your passport and you're going to a different country. Now you're in different security models and different things may apply.
But I think the point of like Cosmos is that we want to make that not feel like you're going to a different country, right? The entire, I mean, I don't know, with Osmosis, our goal was like make cross-chain like composability and UX as good or better than single-chain UX, right? And we don't want users to have to feel like they're going to a different country every time they interact with a different chain.
But they should, because they are. Like, if I take an ETH from Ethereum to Osmosis, like I'm in a different country. Like my security model is fundamentally different at that point.
Aren't you like an EU maxi? Like, isn't the whole point that like...
Well, I've been in Switzerland for quite a bit at this point. I am a local currency, local security model, maxi.
Okay, so it looks like, again, we've got sovereign chains, we've got bridges, we've got IBC, we've got modular blockchains. We're gonna have interchain security. Nothing is gonna happen to Axelar in the near future. It's gonna all be fine. So how does Utopia look like? What's coming next?
Illumination.
Yeah. We have so much work to do. I don't believe in utopia. There's a much higher risk of dystopia that we need to take pretty seriously with all the crap we're building. You know, like Tanuki says, it's a new world full of meta crap, and we have to fight very diligently against that. And this technology is going to be continuously co-opted, and that's very dangerous. I think the best approach, you know, so we have these global censorship-resistant layers, which are really important, but I think we also need local community-oriented layers that don't just, you know, depend on global anonymous security, but do depend on like local forms of accountability and diversity at that level. And that's only kind of just starting, but I think most of us are still pretty far away from it. It's hard to finance those things, and, you know, so we need to find new funding models and ways to tap into, you know, everyone's afraid of governments, and they are scary because many of them are authoritarian. But, you know, I think we also need to find ways to work with them, especially the local ones, and to empower more local governance to push back against the sort of larger authoritarian ones. Yeah.
My utopia is sort of, my parents sit in a local village in Germany, and they hold all their assets secured by their local village of 500 people, and then they like take a plane, and on their phone there's a payment application that does like asset agnostic private payments, and when they land in, and like they also have a local currency in their local village, and when they land, I don't know, in Colombia, like they touch their phone at a payment terminal, and there are assets being moved over IBC to that local zone in Colombia. The local merchant decides whatever currency he wants to receive. My parents pay in whatever local currency they hold. There's an automatic under-the-hood conversion at market rates, and sort of you have this incredibly smooth flow where like they never have to think about this. Like this all just happens under the hood, and sort of this just gets more. This is sort of the simplest use case, but like the more complex use cases are like you do $100 million block trade across many different security zones, and you get atomicity guarantees there, and like all our financial applications can start roaming, like our DAO communities can start roaming these security zones. Yeah, that's I think it for me.
Okay, do you want to say one last thing?
I don't remember what the question was.
What does utopia look like, Sonny?
What's your utopia?
Oh,
Sonny for benevolent dictator of the world.
Sunny, I still remember your profile picture, the one where you were dressed as a monarch. Can you
Yeah,
recover
yeah.
the picture, please?
Yeah, where's your helmet?
I would choose Sunny's security model.
I don't know. I think like utopia is like just more, you know, in my graph that I had, more yellow systems. I think that like building web of trust based systems is like what I'm most excited about. In crypto, we talk too much about like building trustless systems, and that's just not the world that actually exists. There exists a fabric of trust in the world, and I think the purpose of blockchains is to make that fabric of trust more legible and on chain, and then thus computable over, and you can do cool things like that. I don't know, like, you know, finally, as of this month, over 50% of crypto market cap has switched to proof of stake now, which is really cool. But now it's like, what's the next step? I think proof of stake is definitely better than proof of work, but I think there's actually something out there that's even better than proof of stake.
Aren't you a secret Bitcoin maxi?
Yes.
Me too.
I think there's like a web of trust-based consensus mechanism that can be designed. So I don't know.
I agree. It's proof of identity plus proof of stake. So you get like max limits on a per validator basis depending on how many real people are behind a validator. So you limit the excesses of capitalism in proof of stake, and you combine it sort of like with a tapering function of democracy kind of.
That still sounds like too much. Proof of stake is very much one of those like a green system, right? It's in my graph, it was like the libertarian left side of the graph. I think that there is a consensus mechanism that can be built using the yellow side of the graph.
I just want to say, I don't know what utopia necessarily looks like, but I resonate a lot with what Ethan said yesterday, which is that blockchains are tools for sort of rebuilding economic, political systems and institutions for like a digital internet native world that we now live in. And it's clear to me that like a lot of our institutions are outdated, incompetent, or just, yeah, we're kind of at this turning point, I think, for humanity. And the way that I think blockchains can be a significant tool for making that transition. And the way that we get there is by empowering as many people to build using blockchains as possible. So that's why I'm passionate about building this infrastructure that enables anyone to build their own community computers. And that's why like Cosmos is just like a spiritual home, you know?
Amen. The other thing I just want to add though is there's so much of this space is obsessed with ideas around liquidity provision and like almost taking liquidity for granted as like a free good. Providing liquidity is shorting volatility. And like, I don't know if you've paid any attention to the world or nature or any of these things. Like, the world is long volatility. And if you're going short volatility, you're going to get wiped out at some point. And the only way to stay short volatility is to use power dynamics to, you know, suppress the real world, suppress natural shocks and so on. And so this idea that we can just like build liquidity provisioning mechanisms and focus on that will inevitably lead us towards the same kind of dystopia that we currently live in, where, you know, the dealers, the big banks, the money dealers, they run the world. They're all structurally short volatility. The central banks enable them to continuously go short volatility and to, you know, to cut their losses when crisis hits. And so what we need to start doing is stop trying to provide liquidity and start trying to save it. You want to save liquidity. You don't want to be able to just magically go to another country and have all your currency convert at some like frictionless rate. You know, no offense, like what Adrian was just describing. But you want to be able to go to other countries and engage in their local exchange mechanisms and be able to participate in a way that saves overall liquidity, that you don't need, you know, a currency to exchange. Like, the use of a currency is indicative of the fact that you haven't closed a loop in your economy and you needed some liquidity to show up from an external source to close a loop because there's some uncertainty on whether you'll be able to, you know, close it in the future. That's what money is for, is to hedge that sort of uncertainty. And so the more we focus on liquidity provision, the further we get away from actual sustainable economies. And so, you know, liquidity saving is really what we need to be focused on, but that requires us to get our heads out of our asses on all this like finance crap and actually focus on the real world, you know, real world networks of commerce and trade, which we're all still very far from. So,
Okay,
Yes.
I think
DeFi
the conclusion
is just
here.
a meme.
Yeah, that's true. But I think conclusion here is that Ethan is a big fan of pool of money.
yeah, we call it
Check it out.
collaborative finance, CoFi.
Also check out the Noma Vision paper. Also talks about this. Pretty cool. All right, with this, I think we can call it a day. I ran over time. I think my team is going to kill me. Thank you very much for this amazing panel.
Woo! Thanks, everyone.
Like, the loop is not just the loop is not closed because there's a time mismatch.
All right. So we're going to have a short break, get some drinks, get some food, and we'll meet back here in about 15 minutes for the next talk.
Show me your darkest hollow. any kind of organization that is doing anything remotely useful or interesting needs to be able to control the information about what they're doing, right? And, oh geez, I've done the mistake. All right, well, we'll have a reorg of the presentation. And so the point is that we actually need private coordination, but that hasn't happened yet. So as an example, in the last cycle, we saw Constitution DAO. I thought that was very funny and cool, but it turns out that if you're fundraising for an auction and the total max bid is like right there on Ethereum, then like Citadel will just rug you. Great. So if we want these new systems that we're building to allow people to coordinate in new ways to actually work, we need to be able to have private coordination, right? And so a lot of the talks have been talking about various pieces of this. For Penumbra, our strategy is, rather than trying to build something that is fully general right from the outset, let's try to start with one useful application. Because so far, we actually, I don't think, have really seen a private product that actually had product market fit. And so our answer to that is Penumbra. So what is Penumbra? It's three things. First of all, we have a cross-chain, or we have a private proof-of-stake L1 that acts as this cross-chain shielded pool. So we're IBC connected, and when someone moves funds into the zone, right, that's the privacy boundary. Their funds are shielded as they move in. And on top of that, what are they going to do while they're there? It's not useful to just have a shielded pool. You need to have some reason for people to be there. And the reason is that it has a private DEX. So maybe the next question is like, why? So yeah, this is the overall picture of that. We have this like big transparent ecosystem. Hopefully there will be some more private pieces coming later. And you can move in and out over IBC. And once you're inside of Penumbra, all of the actions are private. So this question of like, why do private trading is something that we thought about a lot while we started. And the thought process is basically that because every market is also a market in information, any kind of information leak is also a value leak, right? So when someone is doing a trade on Ethereum and they're being front run, I think it's actually a mistake to think of that as just being about like, oh, there's like, front running or whatever. The fundamental problem is that the action that person is doing is pre-revealing their information. They're operating in a system where they have no way to control the disclosure of the information about their activity. And the fact that they're getting front run isn't actually fundamentally just a problem about consensus, or maybe we'll do some kind of commit and reveal system or whatever. But that's just the tip of the iceberg on people leaking information and that causing them to lose value. As another example, right, if you're a market maker, you're trying to stay flat, and maybe sometimes you'll make a mistake. If somebody can watch all of your trades and figure out, I can predict the like 2% of the time that they're going to do a mispricing, and then roll them over, then that you just lose. So the really interesting thing is that privacy in a trading context actually has this very quantifiable financial value. And so we can try to, our strategy is, let's see if we can use that to bootstrap the creation of the genuinely private, decentralized infrastructure that we want to have by using the fact that allowing people to control their information while they're in this financial market actually allows them to unlock much greater capital efficiency. So that's the like big, thought. The biggest challenge that we have to actually doing that, though, is the state model. And the insight here is that every useful blockchain is going to revolve around the private state, right? Like, why do people want to use blockchain X over blockchain Y, right? It's because on that chain there's some useful private state or public state that everybody is interacting with. And so that means that we need to have some kind of private interaction with that public shared state. And that's really difficult because technologically, the way that you achieve privacy on a blockchain is that you take the execution, you move it off-chain, and you have the transaction, instead of giving a public description of here's what I'm doing, you have a ZK proof that says this state transition was correct according to the rules of the chain. But that means that there's not really a way to interact with the public shared state easily, because how do you know, when you're making your state transition, if you're executing that off-chain, how do you know how that sits relative to everybody else's executions? So our approach that we've kind of generalized out of this single solution for this single application is to try to build kind of an actor model for blockchains. So in this idea, rather than thinking that a transaction is actually going to do some execution on-chain, it's going to call a contract, we say this transaction is going to pass a message to a contract. And each contract is going to execute once per block, and it's going to receive as input all of the messages that were sent to it in that block, and it can process them in a batch. In our case, where we're building a private DEX, we can batch together all the trades, do a single execution, and be done. But you could imagine this also working for other applications, like in an auction, right? Rather than thinking of, oh, well, what's the ordering within a block, you could have the contract sort the messages that it received by, say, the bid price or something like that. And what this means is that the per user state gets to execute asynchronously, off-chain, privately. People are submitting their snarks of their correct verifications of, or the correct executions of their part of the state. And as a side effect, you kind of sort of solve a lot of the most egregious kinds of MEV that exist. Because you don't necessarily now have this idea of oh, there's a concept of ordering within a block. People are just having, the chain is stepping through time, and the time resolution that it's possible to execute the contracts at is the same time resolution that is actually provided by the underlying consensus system. When you combine this with some kind of threshold encryption, you get a really cool, powerful, sort of blind, commit and reveal execution system. All right, so as an example of how that sort of general picture works, here's the kind of rough idea of how we do batch swaps on Penumbra. So this part, in this slide, this is covering kind of the private per user state. So we start off with that user's private input into the batch, and they're going to encrypt that to a threshold key that's controlled by the validators. This dotted line is the kind of division between the private and public state, where below the line, that's all just on the end user device, and above it is on-chain. In order to record what their participation was, in the same transaction that the user spends their input funds to contribute to the swap, they're also going to mint to themselves this private state NFT that's going to commit to all of the intermediate execution state of their participation. So that's the trading pair, their inputs, what address they're going to have the funds minted to, et cetera. And they submit this transaction to the chain. As it's included in a block, the validators can batch up all of those encrypted inputs. We use a additively homomorphic threshold encryption. So the validators can then decrypt the sum of the encrypted batch total without seeing any individual user's contribution. And now they have this public aggregate information, which they can execute against the public chain state to get some public outputs of here's the batch price, and we'll commit that into the chain state, where it can then be used together with this state NFT that records the intermediate execution state to allow that user to privately mint their pro rata share of the batch and prove in ZK that they're minting the correct amount. So this is all the part of how do you mediate the interaction between the private per user state and the kind of aggregated public state. But the cool thing is that now we're doing only one DEX contract execution per block. So what could we do with that, right? And when we look at the public state, we actually have, many different trading pairs that people are going to be executing in the same block. When we batch all those together and get the encrypted inputs and decrypt that, we get this global picture of here's what all of the trading intent was for this block. So rather than executing that, one at a time on individual pairs, well, we're only doing this once a block. Why don't we, go all in and put all this into the big global liquidity graph and do global resolution of all of the trading intent in that block across the entire liquidity graph, right? So if maybe you want to trade asset A to B, but there's more liquidity between A and C and B, perhaps the DEX decides, well, the optimal routing is actually that we do this multi-hop thing. We can also have the chain arbitrage all of those prices on the graph to be consistent with each other so that after we put out these effective clearing prices that are going to be used by the swappers, the chain is just stepping in from one block to the next between one set of consistent prices to the other, with everybody getting their pro rata share of whatever the trade was. So this is actually quite cool, and you get to do all of this computation because you know that you're only doing it once a block. So that's this, global picture. Hopefully that sounds cool. If you want to check it out, it is running. And so if you follow any of these links, they'll take you to the docs of how to, play with our testnets and so on.
Thank you. And on time. Thanks so much. Can the next speakers from the Anoma team come up on stage?
Test. Cool. Yeah, using my left hand is going to be difficult. Let me see. Okay. Cool. Yeah, okay, so the aim of this presentation will be to give a brief introduction to what Nomada is, as well as a brief introduction to private bridges. So to start off, what is Nomada? Well, Nomada is the first fractal instance built on the Anoma architecture. So if you're listening to Adrian's talk earlier, that's what Anoma is, and to learn more about it, I would highly recommend reading the white papers that we're distributing by the entrance. But for the purpose of this presentation, you can think of Nomada as a privacy for assets focused blockchain. So to start this presentation, I'd like to motivate why we care so much about privacy. Well, first, I like to think about it, why am I so into cryptocurrency? Why am I here? And the idea is that I want to be able to transact in the presence of adversaries. The problem with transparent blockchains is that I have to trust that not a single party in the entire world that is watching the blockchain will use the data that I emit for my transactions in a way that I don't want them to. And that creates a N out of N trust model, which I generally would not like to operate under. So I come from a machine learning background, and by now I'm pretty confident when I say that your everyday transactions leak a lot of data about you. That's why we have all these loyalty programs where companies pay you in order to reveal your data to them. And as Target, the American company, showed recently, is that they could use your everyday transaction data to predict if you're pregnant even before anyone in your family knows about it. So that brings us to the first user feature of Namada, which is the multi-asset shielded pool, which will help you keep all of this information private and only to yourself, and then reveal it to who you want to reveal it to. So at a very high level, how this works is that using some really cool cryptography and zero-knowledge proofs, Alice is able to transact freely while still being able to hide what assets she's transacting with, how much of this asset she's transacting, and with whom she is transacting with. And in addition to this, we also have the ability for Alice to have the discretion to reveal exactly what subset of this information that she wants to reveal, and also to what subset of people that she wants to reveal it to. So a very relevant use case of something like this is perhaps what you want to be revealing to the OFAC board to prove that you're not interacting with any sanctioned addresses. But because this is built on the NOMA infrastructure, we can also have things in our validity predicate that prevents us entirely from transacting with sanctioned addresses, and that's all that we need to show to show that we're being law-abiding citizens. So we also believe in ANOMA that we should be subsidizing public goods. And why do we believe this? And I like to think about public goods, I like to think about privacy as having this positive externality, because a privacy set is essentially useful as a function of how many users are already in it. So if we start off with Namada having 0 users, and you bridge your assets over, then this is not a private blockchain, right? Because you're the only user using it. And we could end up in this inoptimal equilibrium to the left, where before we reach a threshold, like a critical threshold of users, no one will want to enter the blockchain. So if we could construct this subsidy schedule whereby at any level we have the benefit being higher than the cost for entering this privacy set, we can guarantee that we always reach the optimal equilibrium with the maximal user surplus. And I would also like to argue that we could make this subsidy schedule finite ad infinity. So to read more about that, I will soon release a blog post on that. So finally, we need to be able to implement this in a way that still preserves privacy. And the way we do that at Namada is through what we call a convert circuit. And the details is a bit out of scope for this presentation, but please come talk to me after this talk. But what happens is that by holding assets on Namada, you accrue subsidized NAM tokens over time that still remains anonymous, and once you withdraw or someone you've transacted with withdraws this asset, you receive your rewards in form of NAM tokens. So, but the road to public goods doesn't just end there, because we believe that there is this idea of, if we want people to bridge over their assets to Namada, there's this problem that if this is done transparently, we have independent privacy sets between every single bridge to Namada, and that creates unnecessary competition between bridges, because essentially in order to get the maximal privacy set, everyone needs to go through the same bridge. However, if we can implement private bridges, we circumvent that entirely. And that's when I pass over the mic to Iraklis, who gives more details on how that will work.
Hello. So, apologies first, my slides have some math. So I guess I don't need to motivate you why we need bridges that much, but for those of you who need some motivation, so imagine you have your star token and you want to convert it to a circle token, and you have to go through some exchange platforms, and those exchange platforms that are not interoperable, so you convert your original star token to some fiat currency, and then from fiat currency you go to the circle token, so that imposes a lot of fees and it's way more complicated, it's expensive and slow. So what is a bridge? It's an entire protocol. It can be a toolkit. At some point, it's a smart contract. It's a special vault account. It's some relay and light nodes logic, which has been incorporated in order to transit the state between the two blockchains. There's a lot of validator logic, and there's an entire orchestration of all of those. So the architecture on bridges looks like that. We have our source chain A, and you have your target chain B. You have a different set of validators, and you want to convert X star tokens for Y circle tokens. So first of all, custodian bridges, we don't like that much because there's a lot of centralization and there's a lot of privacy exposure. So you give away all of your tokens amounts to some third parties, and we don't obviously like that. So trustless private bridges, they on a high level look like that. You don't only have privacy individually on each source chain. That being said, if you're familiar with Zcash style, we don't only need to keep in private the amount of transactions, the target and the source, like we do in the snarks of Zcash, but we want also privacy on the bridge itself. So the bunch amount of transactions that have been held from bridge A to bridge B, we need to keep it in private. So the requirements, we need privacy at each bridge. We want private common state. We want simplicity, speed, and of course a lot of security. So I guess the majority here is familiar with the flow of IBC-style cross-chain transactions. So you have blockchain A, blockchain B. You instantiate some transactions on your source blockchain. This has been monitored by some validators, and then equivalent amount of tokens are being minted into the target blockchain. And then there is some sort of voucher which authorizes to the wallet of the user the minting tokens on the target blockchain. So what we've seen so far that is missing from the exchanging bridges in the private sense is that when some crash is happening on the target chain, for example, either due to adversarial behaviors or due to some network crashes, and ideally when the source chain A is asking to revert back all the transactions that have been going through the bridge, we don't want to reveal that amount of transaction that happened. We want everything to be in private. So in order to solve that, we need some sort of counters to hold all the amount of transactions that have been held from blockchain A to blockchain B in a private way. That means they're somehow homomorphically encrypted without actually ever being decrypted at all, the total amount of transactions. And then when there's a crash and you want to revert back, we have some comparisons which also happen in a private way. That means said that the total amounts are also can be private, but you can learn the result of the comparison. So that is part of our solution. As I said, we use some private counters for our protocol, and we achieve this fault isolation with some secret computing modules, which I'm going to show you right now. So in secret computing, very generic architecture, you have a function f that you want to compute. There are some private inputs, x1, xn, and you have some either private or public output. So f is public, inputs remain private, and the executor, using some secret computing technology, it can learn y without actually touching at all the x's. So if f is a linear combination, some technology that is called multi-party computation can provide some very viable and efficient solution to the problem. So on a high level, suppose that you have those 4 minions, and they have some integer values that they want to keep private, and they want to compute some aggregate functions like the sum. So the way the protocol works, like at the first phase, you can see that the yellow minion is secret sharing its value to the other parties. That being said, when you add all of those values, it adds up to the original value, but if there are no collisions at all, none of the minions understand anything about your input values. So all the other parties compute their values subsequently, and it's not hard to see that if you add all those values, then you end up with the correct sum in private way. So you never reveal your original value. That is for additions, but to do some more involved computation, which involve multiplication, you need some more, you need more logic into your protocol, and you need some sort of structured randomness, which has been distributed into the parties in order to compute additive shares of the multiplication. So the idea is that you have either a set of parties or a trusted party who distributes the special randomness, and then the parties, they run that circuit, and if you follow in a personal paper, you can see that in the end of the protocols, what the parties are holding is actually additive shares of the multiplication circuit. So by doing, in a privacy manner, additions and multiplications, you can build almost anything you want. Actually, we don't have a lot of time to show you how comparison will work in that fashion, but this is the basic idea. So to recap what we've seen, so explicit cross-chain transactions are expensive. Bridges protocols provide a toolkit for cross-chain transactions we can say in one shot. We don't like custodian bridges because they give away too much privacy. And we augment and we improve our existing private bridges technology with fault isolation. And we strongly believe what with multi-party computation, due to the fact that the entire nature of the protocol is in a multi-party way, in the sense that you have multiple validators being connected, can provide a viable solution to the problem of private bridges. Thank you very much.
All right. Well, thanks for sticking in here until the very end. We're going to have one last panel. I'm not moderating this one, but I'm sitting on it. But Yelena is moderating the panel. Please come up. And this is about global communities and the multi-chain ecosystems which form them. Come on up, guys.
All right, so we made it. Last panel of the evening. We heard a lot about very exciting technical, achievements, advancements, shielded transactions. We talked a little bit about the semantics of bridges, if IBC is a bridge or not. But I think for the last panel, we want to bring it back home to some of the more human, political, concerns. So if you don't care about that, if you don't care about humans, if you don't care about society, maybe this panel isn't for you. So I don't know, get a drink, go outside. But personally, I think if we're all here to, build something revolutionary, connect, organizations, people, institutions, then we gotta think about these real hard questions. So the panel is on global communities and multi-chain ecosystems, very broad. So we'll try to narrow it down a little bit with this amazing panel. But before we get started, I have a question for you all. If you can, summarize community in one word, what it means to you, what would that one word be? I'll start, because this was a last-minute request I had of the panelists. I would say it would be love. For me, yeah. So what about you, Spade?
When airdrop.
Those are... All right, okay. I think I know where you're coming from.
I'm going to say communication.
Family.
Values.
Wow, okay. I think that gives us some indications of what our esteemed panelists, I think, care about. So, okay, global communities and multi-chain ecosystems. So, obviously an active and engaged community is a core success indicator of any crypto project. Building a community in a multi-chain ecosystem or multi-chain context, I think poses unique challenges. So can you talk a little bit about how your project, so a few of us are representing validators, others are representing specific projects or app chains. So how does your project approach community building in a multi-chain ecosystem, and what are some of those unique challenges? Maybe Felix, I think you're up
I'll
first.
start. I'm with Chorus One. We're a multi-chain staking provider essentially. So we've been active in a lot of ecosystems, kind of coming out of the Cosmos ecosystem, of course. So we really from the start embraced this multi-chain vision. I think what we're trying to do to kind of get innovations that are built in one ecosystem, kind of port that over to other ecosystems, and trying to ensure that things that are invented in one place kind of make their way to the other ecosystem, and maybe build like a shared understanding of certain problems and terms, maybe even. So one example would be liquid staking, where a lot of the different networks might have like different staking designs, but in the end they all like maybe work similarly, or like come to the same, they have the same problems. And we're trying to essentially build like a core understanding of what is actually deep down the same about that, and trying to inform the other ecosystems of what we've seen in elsewhere, and trying to like port that over. So I think the challenges that many are facing is that many ecosystems will have this like not invented here syndrome, where they try to like reinvent everything instead of looking like around what others have done. And I think I see us as like a player that will try to don't do that and help people like adopt the right things, Yeah.
Yeah, I think finding common ground is definitely something that we all try to work towards. I'm going to kick it to Sebastian, because a lot of your kind of brand, or what you try to advance, the narrative is around interoperability and this multi-chain vision. So how do you think about some of the challenges of multi-chain ecosystem building and community building?
I mean, with regards to community building, I don't know that it's a problem that's inherent to multi-chain, in the same way that, in the same way that all of the different communities that exist on the internet, can exist and sort of flow into each other when there's value alignment, and when there isn't, well, I mean, they're just like more distant, right? So I think with the multi-chain ecosystem, we're naturally going to see different communities have proximity when they have shared values, and have more distance when they don't have when they don't share that many values. I think one of the challenges, though, and something that we need to remind ourselves of, and sort of also aligns with what Ethan was saying in his talk yesterday about how we're competing with institutions and traditional sort of power structures, is that all of us here in crypto, whether you're building on the interchain, or whether you're building on Solana or on Ethereum, or whether you think like Bitcoin is great, our common, I don't want to say enemy, but like the thing that we're combating is are sort of like these traditional institutions that don't represent, I think, many of the values that we all share. And we sometimes need to just remember that and sort of come back to first principles. And so I see that as like a big challenge.
Hello. I would just love to add to that, because what you said really resonates with me, and it's this idea that we're all part of this exit from the traditional fiat system, right? Like, what are we all here for? And crypto communities, what is a technology good for if not to kind of uplift humanity as a whole? We are all part of this, broader goal, and an ecosystem's moat is really its community. It's the human capital that's behind it. So I'm not actually going to promote any single project within this ecosystem, but rather this idea that we're all this big sovereign family as part of the greater interchain ecosystem. And at the end of the day, like, based on all of the conversations that you're hearing, based on all of the talks that you've heard at Cosmoverse, you could kind of see that people are building these little tools to make ecosystems even abstracted away at the end of the day until we basically have this great network of networks, like actually Henry from Penumbra says, into this internet of blockchains. And when we are all migrated over to the internet of blockchains, I think that's when we effectively have exited the fiat system. And that's what we're all kind of building towards.
I would tend to agree. Like, at a very basic level, my view of communities is it's basically a group of people united by either something that they do or something that they believe in common. And I think, like, at various levels, you know, there's the whole crypto community, which is kind of like united in this vision for another model of how we kind of like manage power and money in our society. And then there's kind of like this big underlying idea in Cosmos, which is having separate groups that come together on their own terms and live together, are part of this family, as you say, kind of. So I think like this is kind of like what I think enables us to even like discuss interchain community, basically. It's because we have this shared idea, this shared vision. I think the way we approach it, like, or at least the way I approach it, when thinking about like how Neutron, which is not to shill it, just for context, is a smart contract platform that focuses on like interoperating with other blockchains. The way I think about
Prop
it is...
72, yeah.
Huh?
Prop 72.
Yeah.
We'll get there, we'll get there.
So, oh, well, actually, do you want to take this? Because I can make this comment later if you prefer.
No, I mean, I think like considering how projects sort of balance economic incentives with political objectives is actually like what I wanted to talk about. So I think a lot of us would argue or agree that cryptocurrencies and blockchains are inherently political kind of projects, right? So we talk a lot about governance, we talk a lot about consensus, adversarial conditions. At the end of the day, these systems precede us, you know, since you know we've been intelligent beings. But now, obviously, in 2022, we have technology to mediate these conditions, right? But these conditions are, at the end of the day, inherently political, and the relationships that exist within these systems are obviously human at the end of the day. So technology is just a way to facilitate these things that already exist in the human world. So for your project, obviously these are big, you know, existential questions. But at the end of the day, you have to consider how you balance the political objectives of what your project or your organization is trying to achieve with the economic incentives or the economic objectives of your project. So if we can all agree that there exists a trade-off between the political and the economic, which I hope we can, how does your project approach that trade-off, and how do you think about community building and taking your project to market from that perspective? So a little bit of an intense question, but I think we can all, you know, talk about these trade-offs in a way that is practically motivated. So who wants to take it off first?
I'd like to touch here. So I help co-found an organization in France called ADAN, which is a sort of policy advisory organization that's done tons of work in Europe in the context of the MiCA regulation and all the sort of regulation that's coming down the pipe. And I think it also comes, it does come back down to values, right? So first, yes, crypto is political, and the pushback, the quite intense and violent pushback that we've witnessed in the last year, whether in Europe, in the form of MiCA, or in the US with some of this more recent stuff that I'm not super familiar with but have had some amount of exposure to, yeah, it is political. But you know, what organizations like ADAN and others, and you know, as crypto companies, you should all be paying attention to these organizations and funding them if you can, because they're doing really important work. What these organizations try to do is smooth the gradient with regards to this value alignment, and helping policymakers understand that you know, we align. We're actually in alignment on a lot of things. Just our own biases and maybe even sort of generational, biases that might be also exacerbated by like generational differences, prevent us from seeing that we're actually like aligning on a lot of things. So, I think that, it just comes back down to values.
I would love for us to almost think of regulations as a secondary thing. I know it matters a lot because they have to provide a framework in which you can operate, but at the same time, I think there's a lot of opportunity right now to figure out DAO tooling and how we could govern ourselves, because the demand is there for us to want to self-govern. We're obviously disgruntled by the way that we are being governed in meat space, and these faraway politicians who are out of touch with what we are talking about are the ones kind of in control of things. And the people who are spinning up DAOs and experimenting there are actually saying that, no, we could figure out a better way to govern ourselves. So hopefully, we could move away again from this fiat-based system where the incumbents are somewhere so far away we have no means to even talk to them, and they by no means represent us, even though we ostensibly voted for them. So this whole thing is just a community of people building towards exiting from the traditional system. So even though there are trade-offs right now and we still have to work within the traditional framework, the idea and the hope, maybe the utopian hope, is that we could finally move away from that, build ourselves out of that system, and they follow us into this new paradigm.
All right, okay, I think I'm gonna take it a little bit into more practical thing, where in a way, what we're working towards, I think, is to have this ownership economy type thing where the users of the networks are also the owners. So I think if you want to align that, there is obviously this trade-off where you want to have these early investor VCs, they want to make money and they want to be early, but you also want future users to become owners of the network. So I think there's obviously that kind of tension between kind of rewarding the early adopters and not ostracizing late adopters. And I feel that's basically also the problem that exists in the traditional world where, the crony capitalism and people that are in power want to keep it. And obviously if you have all the tokens and you're not giving them away, you're going to stay in power in proof of stake essentially. And I think that's one of the big issues, that is also kind of not really solved. And token distribution is a big question mark. I guess we had Bitcoin a little bit you were able to mine essentially early by nature of not knowing that it would be valuable at some point. Now it's gone back to the people that are already in power kind of can keep it by investing early in the projects. I guess all of us are a little bit guilty of that in a way, because we also want to maintain that power, but so you need to find a way to not, or get a little bit, reverse the dynamic a bit. And I think there should be much more experimentation in that regard. I think that, what I would say to that.
Yeah, I agree. I think you raise very interesting points. I think to this effect, perhaps the low-hanging fruit of how we make the situation a bit better is, one, recognize that there are various areas and functions in governance. There's kind of the technical parameters of the zone, let's change whatever number the blockchain needs to perform a function. There's also kind of economic parameters which are pertain to incentives, funding, be it ongoing on kind of one-time thing like a grant or something. And then there's kind of the soft law space where it's more okay, we as a community, we make these soft law, these standards for ourselves on how we operate and how we want to think about where we're going and what we're doing. And all of these areas kind of have their own trade-offs, and perhaps we can find mechanisms that actually optimize where we want to get for each of these. For example, for soft law stuff, the rules, our social contract, I feel it makes little sense to opt for kind of a traditional, in crypto at least, one token, one vote model, because actually what you want to maximize is the ability of everyone who is a member of that community to be able to express that opinion, have that opinion heard, right? In other matters, for example, like economic matters, you might actually want the opposite, in which you want not to maximize kind of like the fact that everybody has the same weight, but to enable the strength of preference to be expressed. And so like for all of these areas of governance, there are specific trade-offs for all the mechanisms that we implement. And we're kind of like, you know, using this one-size-fits-all kind of like voting mechanism in Cosmos so far. And I do think that there's a lot of improvement to be made by kind of like breaking down these functions, looking at exactly what we're trying to do and optimize for, and then designing the mechanisms that allow us to make decisions efficiently and kind of like according to our objectives in these areas. So that's kind of like the first thing. And then the second thing is also like, you know, ownership. It's you know, it's a state in terms of like, it's a financial state, but it's also kind of like a mental state. Like the idea of I'm contributing to this ownership economy, to the ownership of this blockchain, is not just like, oh, I have the tokens. It's also like, I understand at least like some of how it works, right? I am actively involved in deciding where it goes. And so for this to happen and to be productive and not just like collectively running into a wall, it requires, in my opinion, two things, which is first, education. And by this, I don't mean like a top-down approach where we're going to tell you what it's like and then you just listen to us and that kind of stuff, but it's kind of like we need the information about the project, the vision, how it works, what is the context around us, what is being done in other ecosystems and stuff, to be shared as widely as possible so that people can collectively, like the community as a whole, can collectively have more refined views over time and make proper decisions. And then the second thing is empowerment. So like over time, as your community matures and people start having tighter relationships, more and more information, and kind of like opinionated views on where you're going as a project and as a community, then you want to give people more and more ability to actually make significant change to the blockchain, the community, the project, basically. So like it can start with very simple things, like recognizing the value of someone's contribution to a community by like with honorific stuff, like even a bloody Discord title or a color can sometimes make the difference, because it's like, oh, actually somebody recognized that I've been here, I've been interacting with people, people know that I'm here, that I exist, right? So it's kind of like the real beginning of this kind of thing. But the way I think about it is that there should be this kind of like ownership or leadership, or call it however you want, ladder in your community, which allows people to get gradually more and more involved. And as they do, they kind of prove the fact that like, one, they're taking initiative, they're engaged in this, they have, you know, at least time at stake. And when they carry out those responsibilities, you can, you know, as a community learn that these members, you know, deserve some degree of trust and give them more power, more ability next time, so that over time you're actually incentivizing people to become more proactive, basically, in their engagement in the community and the project. So I think that's kind of like a crucial component of how we drive this kind of like ownership community and system towards somewhere where we're actually, you know, all in control of this ship we're on.
Yeah, I find it very interesting and significant that the discussions around community building ultimately boil down to governance, and you made some really insightful comments and recommendations on you know, some of the things missing in governance, which would maybe lead to stronger community bonds, right? Things like voting preference is something that we don't represent currently, you know, in a significant way, I would argue, when we do Cosmos governance. So I would argue that Cosmos governance, I assume a lot of you would agree, but it's quite primitive. A lot of things have to happen off chain. You know, when it hits, you know, an on-chain, you know, governance proposal, it's still, you know, maybe not the final state. There's still a lot of questions around accountability, around disclosure. So for my last question here, this is something this is a question I'd like to pose to all of you. What is something that you would like to see represented on-chain from a governance perspective that is currently socialized off-chain or at least isn't represented in the state very well? So I think, Spade, you gave some really interesting sort of hints at some of those things, but whatever is missing, I think, ideally would help to contribute to a stronger sense of community. So think about it from that perspective. It's a bit of a probing question, but I hope you can all come up, see if there's something you think is missing from a governance perspective. What do you guys think?
I'll try to start on it. I don't know if that's completely what you're looking for, what I'm gonna say, but I'll say it anyway. I think. Like we're saying, right, like one token, one vote, this one-size-fits-all approach is not really working that well. I think we're also just seeing not enough governance proposals, maybe even making it on-chain in the first place, or people being like hesitant to even go to that. And very many use cases are not suited to like activate the entire token holdership of like voting on it, where I think the thing that you actually need in a certain way is to build like kind of sub-governance structures in a way that allow you to outsource certain decisions also to like people that are more involved, maybe like in a system like Avril was saying, that people that build up the expertise or like somehow become representatives of a certain area of your project. Let's say it's grants funding, for example, right? That they can make the decision, because like some decisions also need like higher velocity, especially like funding decisions, where you can't like bring every community funding proposal to the community pool, but you actually want more velocity, people that have the expertise to like make some decisions. So I think that's something that would be nice to see. It could just be like also like a proposal where you vote on some committees, I guess, and they are in charge, but then I guess you will need also like systems that prevent capture of these positions, that they can like still be changed and they are based on merit and not necessarily just on whatever power they might have. So I would say that would be nice to see, and I think grants funding is like one of the very obvious ones. I think there's obviously like many more. I think like some of the actual DAOs, if you actually look at people that have been building stuff in this DAO system, I think, I, for my personal experience as part of Lido DAO, have seen like certain structures emerging there that like address that, like distribution of rewards, grants, like it's all like security. There are like different people that obviously have like much more knowledge than the average token holder, and how they get into power is probably also the question that you should be addressing, and like creating these systems to allow that to be sustainable and effective in the end, yeah.
Okay, so I'm not going to sit here and pretend like I have all the answers, right? Maybe one of you might have one of these answers, because right now we can all agree that DAO tooling is extremely primitive, and there's only sort of this stake-weighted governance mechanism that could lend itself to a plutocracy, and we haven't really touched on this idea of this, reputation-based mechanism. How would that even look like? Is it going to be peer-to-peer? How do I, ascribe reputation to someone who has high reputation? How do you ascribe? So all of this hasn't yet been explored, but maybe in the future it can. And the power of this technology is something to behold, because it could be something so granular as something like a family setting. If we're in a dinner table setting and I am a parent and I have children, how do we make decisions? Well, the parents make decisions, and if we are a small corporation, maybe you could use DAO tooling to vote on high-level executive decisions. But if you are trying to replace governments, maybe you figure out a sort of democratic way of doing it via representative government, but that isn't necessarily based on how much money you have in a system. So I think all of that has yet to be explored, and we're still very early in the stages of exploring this.
Are you suggesting that validators are the adults and the delegators are children?
No.
Or the other way around?
The validators are the government officials, the representatives and the delegators are the people who vote on their representative officials.
So I don't have strong opinions about what types of things sort of exist outside of on-chain governance that would need to be brought into on-chain governance. But I do have a thought about governance that, so, you know, we recently started running validators, and I was confronted with this reality that, you know, on-chain governance is like a glorified signaling mechanism, and maybe everybody else had already realized this, but I realized this precisely when I had to put an upgrade binary, you know, on my server, on my validator, in order to participate in the chain upgrade. And I realized at that point that, like, in fact, validators hold all the power when it comes to, you know, basic things like chain upgrades, but whether or not you know, funding proposals actually get submitted on chain. And, you know, during the whole Juno drama thing that happened recently, you know, I was also thinking about it then, and considering what would happen if validators got together and decided to go against the governance decisions that had been made on chain. And so I don't know how we fix that, but I do think that at some point in the future, we are going to witness some sort of drama that is going to top all of the governance drama that we've had to witness so far. Like, there's going to be a shitstorm of like governance drama coming when the decisions that are being made by delegators through governance go against, perhaps, you know, coming back to values, the values of the validators who run that chain, or the foundations who might have influence over them, or any other sort of, you know, misalignment in values. So I'm waiting for that to happen, and I think it's going to be one of those, like, get your popcorn sort of moments.
All right.
Yeah.
Well, on that ominous note, Spade, do you have any final thoughts on this question?
Yeah, I guess my quick 2 cents. I think, like, community as its heart is like something that happens in between people, and so, like, there's only so much that we can put on chain, because sure, like, the blockchain is a network where you can see nodes as people, I guess, but still, like, there needs to be some degree of authenticity in the relationships that are built, and so, like, some of it just, in my opinion, doesn't need to be on chain. What I could see kind of like being on chain and being kind of cool on chain, but that probably has been done a bit, but probably not very well, is kind of like those, well, 2 things actually, like mechanisms that enable people to take more actions. So, like, you know, like community grants, like retroactive community funding and stuff are things that I think are useful, but then also kind of like history / honorific rewards, like on the blockchain. So, like, having your wallet be more than your wallet, but actually being your, you know, a representation of the actions and the contributions you've made to that community, I think is pretty interesting in, you know, starting to build that kind of like network of trust of, oh, like, I may not know who, like, what is the name of that person, but I know that they've been around for a while, and that every time they've interacted with this community and project, they've been very meaningfully adding value. And so I know that their actions are something that I can, you know, rely on to kind of like, in my understanding of this project and what we're doing as a community. So I guess, yeah, that's my 2 cents.
Awesome. Okay, well, thank you to the panelists for answering some tough questions on community building.
Wait, can I just add a last note to that? Yeah, I would love to add a last note and just zoom out into the bigger picture. There is this tendency to get lost in the weeds, details about like funding and whatever, but the big picture is, and I'm talking 10, 20 years from now, and I want to refer to Balaji's idea of the network state. For those of you who aren't familiar, the network state is basically a crypto community that is powered by its own crypto coin. And we're kind of this self-governing system. And it's actually, right now, if you look at the market cap of all of crypto, we are the size of a small country. Like, we're the size of the GDP of like Latvia. We're like right underneath Latvia. So at the end of the day, in 10, 20 years from now, if we figure out governance, it's basically a tool for us to figure out how to govern our own internet country. So yeah, it's just, if you figure out a reputation-based thing outside of just proof of stake, then it'll be really interesting. And we're not going to only be talking about how to allocate capital to fund this thing. We're going to be talking about how to govern our own network state.
Awesome. Thank you, Chango. Really inspiring. All right. Thanks for joining us.
Thank you.
Hey, your phone.
All right, guys, thanks for sticking around till the very end. You're the real troopers here. So now we have time to relax, have some drinks, have some more food, I think. I think there's more food. Yeah, for the next hour or so. Thanks again. And big shout out to the Anoma team for helping put us on and hosting us tonight.
I want